Welcome back students for this new lesson in BMS modeling in MATLAB. Today we are going to model a BMS for discharge current. The cell used is a Kokum cell. Here is the specification sheet where the total capacity of the cell is 31 ampere hours. Nominal voltage is 3.7 volts. For charge condition, the maximum current is 62 amperes and the voltage is 4.2 volts. As we are going to model a BMS for discharge condition, so the continuous current is 155 amperes and peak current is 310 amperes. For modeling purpose, we have to focus on continuous current. So we are going to set a condition for 155 amperes and cutoff voltage is 2.7 volts, which means that the voltage should not drop beyond 2.7 volts. The operating temperature for discharge condition is -20 to 60 degrees Celsius. This means our temperature should not go below -20 degrees Celsius and above 60 degrees Celsius. And for charge condition, the range is 0 to 40 degrees. In this session, we are going to model a BMS for discharge condition. So this is a script which we are going to run and it will automatically open a BMS model. It will run and we will get out results. The code written here is to open the system. This is name of my file, BMS model. You can put here whatever you have saved in. This is to load the current profile. I'm giving here the NEDC, that is the new European driving cycle, which you can easily get on Google. Here is the set parameter code. This is to set the parameter to stop time in our BMS model. So our NEDC current profile is for 1180 seconds. So I have just entered here as 1180 stop time. Here is the cell serial number, 8C continuous discharge rate and 15C peak. The cell capacity is 31 amperes. These all are the cell specification of length, width, thickness, area, volume. You can pause the video and you can have a look at it. This is the connective heat coefficient, that is 5 watt meter square per Kelvin. This is the initial temperature of the cell, that is 293.15 Kelvin, which is the ambient temperature, 27 degrees Celsius. These are all experimental data which we got by testing the cell. State of charge, that is SOC, C1, EM, R0 and R1. This is to open the BMS model. This is the Simulink model name and this is to plot the graph. So we will run it. Here is all the graph of the parameters which we are inserting in the cell modeling, like internal resistance, which is the function of state of charge. This is a 3D graph. Then this is a resistance variation with respect to SOC and temperature. This is voltage variation with respect to SOC and temperature, and this is for the capacitance. This is a BMS model. This is a BMS algorithm which we have inserted in this to operate the terminal voltage, the temperature, the current. This is a lithium ion cell model we have made and here is the output. Here are the indicators for display purpose. It is green, which means it is in the condition which we have set. If it turn red, it means it will exceed the limit which we have set. So let's run it. Here are all the plots. This is our NEDC cycle which we have inserted current profile as input. This is the current which we are getting as an output. As we have set current limit as 155, it was mentioned in the cell data sheet. So the current profile is under 155 amperes. So it is showing all the current profile which is under the limit. This is discharge trigger. Discharge trigger means if it's showing 0, it means the parameter have no exceeded the condition limit. If it gives 1, it means it has exceeded the given limits. Now let's design our BMS model. So first we will open our lithium ion cell model. Here is our lithium ion cell model. We have to make the certain changes in it. We will delete our output block. We will delete the current. As we are designing the model for discharge current, the NEDC profile is for both purpose. Here we have to insert the current as NEDC current profile input. As this cycle is used for both purpose charging and discharging, and we are going to model it for discharge current, we have to set the limits for current. Positive current means discharge current, and negative current, which is showing in the graph, means the charging current. We now require the positive current. We will open the saturation block. The lower limit is 0 as we want the positive current and positive input. So this is what we are getting output as discharge current profile for 0 to infinity. Now we will insert the subsystem block for our BMS model. And name it as BMS Discharge Model. We will open it and first design our BMS model. So basically we are building the model for 3 conditions, that is under voltage, over voltage and temperature. So we require 3 inputs. So we will just click on control and drag it to copy it, the input. First we need the terminal voltage, then current, and lastly the temperature. So we will insert one subsystem block for protection logic and name it open it. As we are giving 3 inputs, again click and drag it. First is terminal voltage, second is current, the third is the temperature. and the output which we want is current. So this is a protection logic block. So it will basically give us a discharge trigger whether yes or no to continue further. If it is yes, then it will proceed with our current which we have given it as input. So our voltage, as we want to give the condition, which means it has not exceeded below the under voltage which has been specified in the data sheet, which is 2.7 volts. We will insert a relational operator, as it should not go below 2.7 volts. So here we will keep it as less than equal to. The output of this block will be in 0 and 1. So I will insert a constant block to set a limit 2.7 volts. Name it as under voltage. Then for the current, it should not exceed 155 amps. So again I will click on control and drag this to copy it. So here it will be greater than equal to. And again for setting this, control click and drag this to copy, and here we will change it to 155 and name it overcurrent. For temperature, here is two limits, minimum limit being -20 degree and maximum being 60 degrees. So we require two relational blocks, a constant block to set the limit, here we will keep it greater than equal to for our max temperature limit, which is 60 degrees Celsius. Or 333 kelvins. And lower limit is -20 degrees, which is 253 kelvins. And name it as minimum temperature limit. So when all the conditions are true, it gives a discharge trigger. For temperature, it should be either between the 253 and 333 kelvins. So I will insert an OR block. So if either it is true, it will give output as 1. Double click, make it rectangular shape and OR operator. So if it's within the max temperature and minimum temperature, the output will be 1. And even if either condition is true, again we want 1 as an output. So we need to insert again an OR block. Now we have 3 inputs, so the number of input port will be 3 and icon shape will be rectangular. You can choose any shape if you want. the output will be 0 or 1. We can double click on this link and name it as under voltage protection trigger. Here we can name it is overcurrent protection trigger. And here temperature protection trigger. This is our protection logic block. Here is the discharge trigger where we will get 0 or 1. So we will connect the voltage to voltage, current to current, and temperature to temperature. Here we will get discharge trigger as an output. Here we will add go to block and name it as discharge trigger. Here the tag visibility will be global. If we keep it as local, we will use from block in this submodel. If it is global, we can use it anywhere in the whole model, so we will keep it as global. Now we will insert one switch. So in switch, the discharge trigger is equal to 0, means it is safe condition. If it is 1, this indicates that it is getting over limit above our protection logic block. So I will keep the switch equals to 0. If it is equals to 0, we will continue with our current, and if it is not 0, we will give it as output as 0. For that I will insert an constant block and connect here. The constant veil will be 0. This is the output. We will name it as safe discharge current. So this is a protection logic block for our BMS model. This is our BMS discharge model. For simplification, we will make the current input port to 3. Now connect it and name it as initial current input. Here we will give one go to block because with safe discharge current we have to give it to lithium ion cell model. Go to tag will be discharge current, and again the tag visibility will be global as earlier. Now insert a from block to give this discharge current as an input to lithium ion cell model. So we'll click on update tags and choose discharge current, then stretch it a little bit. To compare it to a final output, we will assign one go-to block to compare between the initial current which you have given as an input and output from our BMS model. Tag will be discharge current input output, that is IO. The two inputs from our BMS discharge model will come from lithium ion cell model. So we need some changes in that. So we are not taking the terminal voltage here and the temperature. So we have to give this terminal voltage and temperature as an input to our BMS model for monitoring it. Here we will add one go-to block and output port and name it as terminal voltage. And we will add one more output port to our temperature. We are not using this current, so we will delete it. And instead of this current, we are giving current input as discharge current from our BMS model. So we will change from current to discharge current. Now we will connect this. And now we will add from block. Update the tags discharge current initial, drag this, make it as discharge current final output. Adding one more and making it terminal voltage, then temperature output, adding adding open circuit voltage, that is OCV, R0, R1, C1, P0, P1, total P loss and state of charge, that is SOC. Here we will add discharge trigger. To total we have 13 output. We will add one scope block, double click on it, then go to settings, give number of input ports 13, set the layout and click on apply. Extend it a bit and join each of them. Double click on the signal and name it discharge trigger. Initial discharge current. Final discharge current. Terminal voltage. Temperature. Open circuit voltage. Internal resistance R0. Internal resistance R1. Capacitance. Power loss at resistance R0. Power loss at resistance R1. Total power loss. State of charge. Now we will manage it properly. So this is a full lithium-ion cell modeling with a control unit with the discharge BMS model. So we will just save it as BMS model 1 and save it. we forgot to add lamp to display whether we are exceeding our protection logic block or not. So double click on it and type lamp. So this is our lamp. Double click and label will be hidden. We will add one more signal which means if input is 0, it will give a green signal. If it gives discharge trigger or as 1, it will give red signals. Click on apply and then OK. We want 3 of them as we are monitoring voltage, current and temperature. For naming, right click on it, format, block name and on. Same for the second and the third lamp. Name it under voltage, overcurrent and temperature. So we have to connect these lamps with our discharge trigger protection logic. Just click on it and we will get a link to connect, and then open the BMS discharge model, then open the protection logic block. And as we are connecting the lamp for under voltage, we will just click on this signal. So here we will get the connect option. Just click on it and get connected. Similarly, we have to connect other lamps to overcurrent and temperature. Click, open protection logic block, click on overcurrent protection and connect it. Now for temperature, connect protection logic block and then click on signal and connect. So now we have connected the lamp. So this is our complete BMS model. I will just save it, and now we have to do certain changes in script file. Now we have to name it as BMS model 1 and we have to change it everywhere in the file. Save this and run. Here it is exceeding the temperature and the red light is there. So it should not go below 253 and we have given greater than equal to. So let me just change it. Let's save it and run it again. So click on the scope and here we can see our output. It is an open circuit voltage. It is not giving, or it is not going below 2.7 volts, which we have set. The temperature is not going above 333 kelvins, so the discharge trigger is 0 every time. The initial current is also not exceeding the maximum current, that is 80 amperes. So we want to check whether our BMS model is working properly or not. We change the current to the value of 60 amperes. We will again run it and check. So here we can see it is going above 80 amperes. The initial discharge current is going above 75, and now the final discharge current from the BMS model is not exceeding 80 amperes. We can also see from discharge trigger, when it exceeds 60 amperes, it shows discharge trigger as 1. And here it is dropping suddenly and again rising, because as in a switch it is given, as it is 0, then our discharge current will be same as input current, but if it is not 0, the discharge trigger is 1 and we get 0 as an output. So that's all for today. You can try it for charging model also. We also have the parameters for charging, like maximum current, which is 62 amp.